could do with the design or architectural analysis. And then there's a few of them that you would just say, hey, y'all really need to use configuration management. So you'd spot that at the start of the project. And here's just a sample from the spreadsheet where I had a checklist here of mostly yes and no boxes. And a large part of this presentation will be going through the different columns and how many yeses and nos there are. Okay, some of the observations on my methodology as opposed to the checklist items. Not everyone would always agree with me on what choices I made within these columns. So they have been peer reviewed. Noble was kind enough to peer review it. John Bradbury's peer reviewed it. Todd Coward peer reviewed it. We also would like to have some of the people from the static code analysis group to look at it as well. Some people may have written issues that I didn't find in Orbit, so I say we never write issues on that or never have. And maybe there are some, but I just wasn't able to find them. And some of them are a bit ambiguous, so there might be some discrepancy with other analysts on how to interpret exactly what the checklist item is talking about. There are 120 checklist items. And anytime in this presentation that I've quoted from one, it's italicized, as you can see in the bottom of the slide here. Some of them can be found with multiple types of analysis, so not all the numbers add up the way you think they might. And there is duplication amongst the different checklist items, especially when you look at the C items. A lot of them are duplicated in the C++ section. And you can even see two here for the C++ where they're talking about class operators. You have two checklist items. They're somewhat different, but you can see they do overlap. Some more observations here. Some of the checklist items are not, in fact, most of them are not written in the form of shall statements. They're written in terms of avoid, minimize, more ambiguous terminology as opposed to shall not or shall do. Some of them are written as do statements, such as minimizing control flow complexity, and some are do nots, like avoiding go-tos. The C++ section has a different style than the other sections. It's kind of almost these be aware statements. Be aware of error associated with functions causing unwanted side effects in a function. And there were 7 items that I put double question marks in because I found them to be ambiguous enough that I didn't want to make decisions on them. And so of the 120, I really only evaluated 113, leaving these others for either people to who were better at it than me to look at them, or have somebody else peer review it. Unfortunately, inside the checklist items, they don't give examples to really illustrate what the author was thinking. Okay, in the first column, I did a severity summary. And once again, 1 is bad and 5 is relatively trivial. And most of the code issues fall into either a 4, which is a non-runtime issue of a problem of some kind, or 3, 2, or 1, where some kind of fault occurs in the running of the software. There was one compiler error, so we wouldn't see it, so I wrote that as NA. And some of them were, it depended on the context how severe it was, as opposed to dereferencing a null pointer, which is always bad. And then there were 12 that were more risks than issues. And so some examples here for the incorrect precedence assumptions are going to give you the wrong answer, so that would be a 3. A 4, in this case, deals with code maintenance. Any global variables, I could think of cases where it'd be trivial and other cases where it'd be catastrophic. And not using version control tools would be something we would write a risk against as opposed to an issue. Coverage with code analysis. I found that 33 of these, the static analysis tools that we use would actually present warnings that we would find these issues with. Some, it would give you a partial answer, such as if the example here being parameters passed to a function in the wrong order. Well, if they're different types, the tools will tell you, but if they're the same types, it wouldn't. And in orbit, I found there was inconsistent use of a couple of different checklist items, where the example here being use of numeric literals, just numbers appearing in the code. And I do know that sometimes we've written them, but if you wrote all of them you found in most source code, that would be somebody's full-time job. I found that of the 113 that I evaluated, we could cover 111 issues. There were a couple that we couldn't cover, one being the one that would be a compiler issue, so we would never see it. And then there was one written here, as you can see, 2 mini parameters. So how many is too many? Then I tried to make an evaluation of whether we should cover them. Some we absolutely should cover, and most of those we already do. There were a few that maybe we should cover them depending on feedback from the project. And I know Darrell Lynn is working on a project about, I forget the term, about getting feedback from the projects about what kinds of things they are interested in finding out. And then there are certain things that we just shouldn't cover, such as the use of single entry and exit points in the program, which if you try and enforce that, you can get some really complicated functions trying to force it to only exit one place. In fact, the checklist item gives a lot of caveats on that about when and when not to try and do this. And once again, some of these things, about 97 of the checklist items, you could actually write an issue because it's an atomic thing, something you could actually find. But about 16 of them were more, not so much vague, but risk-oriented as opposed to issue-oriented, such as minimizing dynamic binding, which can be a real problem when you're trying to use polymorphism. Trying to follow the logic of the source code can be very difficult. It can also make it difficult to find where problems are if you're not quite sure which class is actually causing the problem. So it's something we should be aware of, but it's not something that you would actually write an issue on. About 23 of the checklist items can be found with the static analysis tools we have. And a couple of them are, sometimes it'll find them, sometimes it won't, such as checking data validity. It'll tell you if you passed in a parameter that's a pointer and they didn't check it for null. But it's not going to tell you that they didn't check an integer for a range bounding. Text searching. A lot of these you could actually use either simple or somewhat more sophisticated text searching in the source code, and to find these issues, such as our cases. Switch case constructs always have a default. So you could write, in this case the example is finding all of the lines with default and switch in them, so that you can manually just read through the results to see if there's a switch that doesn't have a default after it. This is a simple example, but the real one's a little bit more complicated. Code review is the way to find about 50 of the checklist items, such as errors associated with control flow. The tools will find certain things, such as dead code, but a lot of the logical errors it's not going to find, but you would find them by actually reading through the code. And then other kinds of design analysis or architectural analysis, OO analysis, can be used to find other items within these checklists, such as error associated with memory you might be able to find with dynamic testing. The class operator assignments you should be able to find with the object-oriented diagrams and analyzing those. So about 29 fall into that category. That didn't change it, did it? Okay. And then about 4 of them I found that you would find at the start of the project. You know, are they using version control and configuration management? And if they're not, they probably shouldn't have gotten the contract. The enabling the compiler warnings, bug tracking tools, and use of data typing. You know, if they're writing the GNC in Perl, it's probably not a good idea. The next steps here. One thing I started to do was try and identify in Clockwork and FlexLent which warnings apply to each of the checklist items. And other things appeared to be more important, so that's something that I need to work forward on. It's one of those things that it takes quite a bit of time, and if anyone's got an intern available, that would be nice. And also writing the regular expressions I have written here, but I was doing work on MPCV, and I've basically got that finished and is in peer review right now by Ashley Lemasters. Okay, and in conclusion here, of the checklist items, we can cover about 111 of the 120, which is about 93%. Static code can cover, or static code analysis using the static code analysis tools, we can cover about half of those items for which we would write temps. Of the 70 checklist items that I identified that we should cover, I put down the totals on 36 we can cover with static code analysis, 16 with the text searches, 14 with code reviews, 36 with some other type of analysis, and the 3 during the project startup, which, and if you add those up, it's more than 70 because some things, some types of techniques can be used on multiple checklist items at the same time. And some of the checklist items need 2 different types to get it completely covered. Of the 70, we already cover about 33, or about half of the checklist items that we ought to. And as my final conclusion, NASA IV&V should develop process assets and modify methods in the NASA IV&V catalog of methods to ensure that all the checklist items that should be covered are covered. And of course, I'm early. So are there any questions, or can I even take questions?
Yeah, you can take questions. You have a few more minutes. Any questions in the room? That there's not a one-to-one onto relationship between checklist items and analysis methods. So at times, in certain items, you would need 2 different kinds of methods to cover them. Certain types of methods would cover, you know, all of some subset of the checklist items and partial sets of other, partially cover other subsets. Okay. those standards do exist. And I wasn't made, it wasn't a scale that I had made up for this project.
Yeah, that was my question. You plan on making a standard, that's what you said. Correct?
Yes.
Yes.
It was.
Yes, that was my question, because you made it up, that was gonna be what was the logic on.
I know they're available internally to the IV&V facility. I don't know if they're available externally.
I actually, you have something online, I am an external person. Thank you, I do appreciate your explanation.
Are there any other questions in the room? How about on the telecom? Fine? All right. If there are no more questions, we will go ahead and get started with the next presentation. Can go ahead with the breakout session, take anybody right there, okay? Thank you. And the camera will track me pretty much while you step up and notice your towel. We want it all colors.
Okay, this is the, there we go. A nice picture of the top of my head.